the top-down strategy. Okay, the advantage is when we are doing the integration from top down. Okay, it means we have completed at the higher level of the the hierarchy of our system. And then the major advantages will be if we are going to have the flaws or the defects at that high level, at the top level. So it means the more we are doing the testing from what we have completed, we able to identify the flaws earlier. Okay, so it can be the advantage. Okay, and once the input output function has been added, the representation of the test cases will be easier because we already have the structure. It means the backbone of the software is already there. When we say from top to bottom, it means we are starting from the main to bottom. So it means we already have the backbone. So once we added the terminal functionalities, the input output functionalities, then the test cases, preparation of the test cases will be easier to be done. Okay, and the third advantages will be the early skeletal program. It means the backbone of the program, it's already there. The main program, when it's already there, then we can already know the backbone is there and it will be easy for us to proceed. Okay, then the disadvantages of the strategy is the stop. Okay, so since we are doing the top down strategy, it means we have completed the higher part of the system. So any missing part or any missing of the code happen will be always at the lower level. So when we say there is missing happen, then we need to produce the stop. Okay, and this can be more complicated. Okay, then the second disadvantage is before the input output functionalities at the terminal modules has been added, the representation of the test cases by using the stop can be difficult because we don't have the actual functionality yet. So just by using the stop, we cannot come up with a proper test cases yet. Okay, then the third disadvantage is the test condition may be impossible or it can be very difficult to observe what can be the test output will be because we don't have the actual functionality yet. So it will be a bit difficult to do the observation on the test output. So this will be the advantages and the disadvantages of the top-down strategy. Then goes with the bottom-up strategy. So bottom-up strategy means when we have completed the bottom part of the system hierarchy, then we will start to do the integration testing from bottom to up. Okay, so the advantages will be when the major flaws or the defects or any mismatching happen at the bottom. So it means we are doing the testing and we able to identify any issues at the earlier stage. Okay, then the second advantage will be the test condition will be easier to create with the input output functionality. So here when we set bottom up strategy, we have completed all the terminal modules related functionalities. So when we have this input output functionalities, what exactly the functionality the system has to do, so it will be easier for us to know the test condition and also the observation of the test result will be easier. So when we have the actual functions code, it will be easier for us to come up with the test cases. Okay, then the disadvantages will be since we have completed the bottom part, we start from the bottom part, any missing code happen at the higher level. So it means we need to produce the driver, okay, to do the replacing of the any missing code on the high level. So the disadvantage here is we need to produce the driver module. Okay, then the program as an entity does not exist until the last module, the main module has been added. So when we are having all the terminal modules going up, when we don't have the main structure, the main backbone of the program, it means we don't have anything yet. So until we add the main module, then only we can say that it is exists. The program main module or the backbone is exists. Okay, so this will be the advantages and the disadvantages of the bottom-up strategy. Okay, so non-incremental, we have no strategy to choose because each of the module will be tested independently, individually. Then we will do the final integration as a whole system before we can do the integration test. Okay, so before we go to the next level, okay, so this one is the V model. Okay, so as part of the software process model or the software development model, we have this one. Okay, but I think you have not been discussed this, because in your 2163 software engineering, I don't think this model has been included there. Okay, they talk about waterfall, they talk about what is that, incremental, agile, this and that, but I think there is no V model. Okay, this V model is actually giving importance on the verification and validation throughout the software development. Okay, so the V is actually stand for the verification and validation. So in our chapter 1, we have discussed what is these two, verification and validation. So if you see throughout the software development life cycle, they will be involved of verification and validation. Okay, so if you see in each of these stage, okay, like our analysis stage, our design stage, our coding stage, what we are producing, the artifacts which we are producing need to be used for our testing preparation. It means when we want to do our validation later, we have to make sure that we are referring back to what we produce during each of these stages. So if you see during the analysis stage, you are going to work on your requirement. Correct? So it means you gather the requirement, you analyze the requirement, you document the requirement. So the capturing of this requirement will be needed for us to develop our acceptance test later. Any idea what is this acceptance test? What is this acceptance test? What is acceptance test? User acceptance test, correct? Who will conduct this testing? User. Sorry? The end user. Am I right? So later we will discuss about it more. Okay. So when we say that end user will be the one giving us the final result. Either the system is okay or not okay. Can they accept it or not? So as part of the user acceptance preparation, we will need to refer back to the requirement which we gather from the end user. Because for us to say that this requirement has been included, it will be accepted, who can confirm that? The user. So that's why the requirement which we gather from the end user will be needed to prepare our user acceptance test later. Okay, then when we move to our design stage, in design stage we are going to have all type of design. Okay, your architecture design, and then you are going to have all the UI design, the prototype, the data, whatever needed, the entire design translation of your requirement into design we will need to prepare our integration system testing. So for us to successfully do the final integration of the system, we need to refer back if this is follow what is mentioned in the design document or not. If this architecture is what we have designed and that is how we have integrated or not. So we will need back our design document here. Okay, then during our coding stage, when we are doing the development of the coding, the implementation of the coding, we will need this code to conduct our unit testing. So if you see, this V model is give importance on the verification of each of these artifacts being produced at each of these stages, because we will need to refer it back to develop the testing. So for us to do the validation later by conducting the unit test, by conducting the integration test, by conducting user acceptance test, we are actually referring back to what we produce. So this V model is giving importance on the testing by doing the verification and validation in each of the stages. Got it? Okay, so we have discussed at the unit level. Okay, then we have discussed about integrating. Okay, then the next thing will be moving to the higher order testing. So at the final stage of the integration, so let's assume we have done with all the individual units, we have integrated as the individual module, and the module has been integrated as the subsystem, and then the subsystem has been integrated as a whole system. So now we are actually at the system level, or we call it as a higher order testing. Okay, so this is actually start from the end user giving the requirement, and then this is the objective, the specification, the design, structure design, the interface specification, the code. So each of them will be needed for different level of testing, which is start from the unit or the module testing, then integration testing, and once we have integrated as a system, then we will start to have the function testing, system testing, and then user will involve with the user acceptance testing. And when we want to do the installation at the client side, then we will be having the installation testing too. Okay, so this is movement of the system, and also the testing will be included. Not only this, but we are going to have more. Okay, so for the functional testing, so I believe that this is what we are discussing for the past weeks. Okay, so for your assignment, we are actually not doing any lower level testing, because whatever system which you have selected for your test plan, test case preparation, we are not having any access on the code. Correct? You are choosing Shopee. Are you accessing their code? Can you test their code to confirm the functionality? No. So we are not at the lower level. We are actually doing the higher level testing. So it's always start with the functional testing. So here when we said functional testing, without touching, looking at the source code work at the back, of course it's going to be black box technique. Got it? Hope you are very clear what is a white box and black box. So normally this testing is where we want to see if the program or if the system is doing according to what is mentioned in the specification or not. So it means we have our expected result. We want to see this is what the system suppose should do from the point of view of the end user. If I give this input, the system suppose should display this. If I do this, the system suppose should give me this. So this is what we have mentioned on the specification. So when we do our functional testing, we want to see if the function is doing accordingly and give me what I expected to see. So if the actual result given by the system during the functional testing is tally with what I expect, then it's a pass. It means there is no gap happen. There is no issue happen. There is no defect happen. But if I expected something and the system or the program is giving me something else, then it means it's going to be fail. So this fail due to what? That is what we need to identify, and we need to do the debugging later. Okay, so functional testing is all about where is the issue, where is the gap between the system and also what mentioned in the specification. If these two working together, there is no gap happen, it means they are working fine. If there is any gap, there is something which is not tally, something which is not same, we expected A and it's giving us B, then it means there is gap happen. So that gap is what the development team need to analyze, need to identify, and they need to do the debugging. Got it? Okay. So then when we said system testing, so system testing will be to compare the system or the running or the executed program to its original objective. So here we will be looking into what the system must do as an overall objective. When we say system testing, we are talking of the overall system. So we want to know as the overall system if the system is fulfilling the objective or not. So here when we say system testing, we don't go for the specification one by one, but we are going more into the user objective or user documentation and also the program main objective. If you say the system must do this as an objective, then is those objective has been fulfilled as a whole system or not. So for your final project, okay, students sometimes they are very confused of this when they are working in a team. Okay, so if you see when you are proposing a topic as a pair, okay, it means two of you are producing your own individual part, and this need to be worked together at the end. Correct? It means you need to integrate them, become as a whole system to fulfill as a whole objective both of you mentioned. I hope you guys are clear of that, especially when you are working in a pair, because this question will always come. Are we preparing the same proposal? Are we having the same objective? Are we having the same module, the same functionality? It depends with what you are proposing. So let's assume you are proposing to a system and you have two different side of user. One person say that I'm going to come up with the customer side, and one side of the person say I'm going to come up with the admin side. Got it? So in that situation, are we going to come up with the same proposal? Are we going to come up with the same module, same functionality? When you are doing your literature review, are you both doing the same literature review? No. But when you say that this will become one system, you both need to integrate your work. You both need to integrate total of your maybe 8 to 10 modules, functionality to work together. Because what the admin is managing, that is what the customer suppose should see. And what the customer is giving, that is what the admin suppose should managing. Correct? So the same thing goes here when we say system testing. Okay, you guys project 2, is it? No, project 1. Project 1 now. Have you go for briefing? Have you started proposal?
Yeah.
Year 1, yes. Year 2? Started proposal. Submitted proposal. Approved by supervisor. Haven't? You did not submit yet or not being approved yet? Year 1 submitted. Where is mine? Where is my one and only project student? Hi. Is your proposal approved? Have I approved your proposal? He's working alone. Okay. So if you see, when we set system, okay, when you are working alone, of course you are the only person, that is the system. But when you are paired in a project, okay, you have to be careful how you are going to integrate them, because when you integrate, your objective need to be fulfilled as whole system. So this is nothing much about the internal specification, external specification one by one, but it will be both of your objective, what the system supposed should do. Because when you go to your deadline, you will see system preview, system final testing. All this is actually as a whole system. It means you must integrate them before you can test them with your supervisor, test them with your moderator. Because when you two are proposing, you two need to come up with one integrated system at the end. Okay, that's why you have to be very careful when you pick your pair, because I have this one experience like your senior batch like years back. Two of them, I think they were couple, boyfriend, girlfriend, and then they have issue while doing the project. They break up and the system also break up. Can you imagine that? Until they don't even want to see each other, they don't want to work together while they are working on project 2. This is old batch of RSS before, like 2018, 2019 batch somewhere, and we don't have these big numbers of students that time. We don't have, big crowd. It will be very small student and I cannot fail them. Okay, so when you are choosing a pair for final project, can you tolerate them or not? It's very important, because at the end, it's system testing, not individual module testing. Okay? Okay, so under the system testing, we will be discussing 15 different categories of system testing which we can conduct. So once you have integrated as a whole system now, we can do different type of testing. So here, all these 15 types of testing give importance on the black box technique now, because we already integrate as a whole system. Do I need to go and dig back the source code at the back if the source code is working fine or not? No. We are giving importance on this source code, on this white box testing at the lower level. So that's why it is very important for us to start the testing from the lower level when it's still an individual unit. So that's why we start with the unit test, and then we do the module test. Then once we integrate as a system, we are not checking back the source code. We need to move it into the next level, which is more to the black box technique. So all these 15 categories of the system testing here will be more to black box technique. Okay, so each of the slide is actually discussing each of them. Okay, so here is just to go through in a simple summary table. Okay, so I will use the slide. So the first one is the facility testing. So facility testing is something similar to the functional testing. Like just now we talk about functional testing. So the facility testing is also doing the similar thing where we want to check if each of the function is fulfilling the objective of what they supposed to do. So here we will be checking the objective of each of the function based on the checklist. We want to see what is the objective and if this function fulfilling those objectives or not. So we call it as a facility testing. Then the second one is volume testing. Okay, volume testing, we have this viewer which is always cause confusion. I'm not sure if you have heard it, you have dealt with it. We have volume testing, we have load testing, we have stress testing, and we have performance testing. So these four kind of like very close to each other, and it will be conducting, and we still like wondering what is each of them do. Okay, if you see as a general, four type of testing give importance on the performance. If the system is performing well or not. Nothing about functionality. Yeah? This four is giving importance on the performance. But the way we are testing the performance is from different sides. So when we set volume testing, when the system deals with heavy volume of data, volume is only about high volume of data, nothing about other type of load, only data. So the more the data is growing in the system, in the server, okay, can the system still able to perform well or not? So here the aim of the volume testing is we want to see if the system able to handle the high volume of data to still work and fulfill the objective or not. Okay, so volume data is more to, volume testing is more to data. Nothing about device, nothing about network, bandwidth, user, nothing. When we said volume test, it's all about data. Because let's assume you have deployed the system, the first 1 month, everything working smoothly. Because no much data yet. Let's assume after 1 year, after 5 years, after 10 years, the data will be growing. So can this program, can this system able to support this high volume of data or not? When it cannot support, then the system cannot perform well. Okay, so that is volume testing. Then the next one is stress testing. Okay, stress testing, we still want to see the performance of the system. Okay, but here when we say stress, it can be due to heavy load, where the load actually can be any type of load and data can be part of the load. So it means when I'm stressing the system by increasing the load, it means the data becoming more, the devices access to the system become more, the transaction happened more. Okay, the network bandwidth, all this is actually becoming more. So when we are stressing the system by increasing the load, what happened to the system? Can the system still able to work based on this stress given or not? That is what we want to see. So this is always like what you guys face when you do the registration using intranet. So what happened when the student number increase, when the access of the device to the same server is increased, the system becomes stressed and it cannot support the performance. Okay, so the difference between volume testing and the stress testing. So volume testing means Could the typist cope of a draft of a large report? So it means when we refer to large report, we are referring to high volume of data. And when we say stress testing, it means we are giving a certain rate here, rate of 50 words per minute, and can the typist handle this stress or not? So the same thing goes when it comes to a system. When we set volume testing, it's about large volume of data. Can the system handle it or not? But when we set stress testing, it means when we have certain rate of limit for the stress, and when we are giving more than that, or when we are giving certain maximum or minimum rate to follow, can the system handle the stress or not? Whatever is it, it will still affect the performance of the system. Okay. Then do I have the load testing? I think I don't have the load testing. Then we have the performance testing. So load just now is actually different type of load. So when I give this load, what happened? We want to see. Okay. And then we have the performance testing, where the aim of performance testing is we want to see how the performance of the system, how the efficiency of the system, how fast is the system respond for each of the requests given. So it means when you said your system must respond back to the user like within 5 milliseconds or 10 milliseconds. So we want to test the performance. Can the system follow that rate or not? Or is it the user is waiting like forever and ever for the login to success, for example? So this is showing the performance of the system, and when we say performance, it's all about the response time. How fast the system responds, or how slow is the system to respond. Which one you prefer? Are you going to sit and wait? Are you willing to do that? No matter how good is the system look, no matter how good is the system function, but if the response time is keep on dragging, you will not like to use the system. That's the truth. So performance testing is very important to prove that the system's response time is as what we mentioned. Okay. Okay, then sorry, I'm back again. So I have discussed that before. Then the next one is the usability testing. So usability testing, user interface testing. Okay, they are more on how is the user interface, how the user feel about the user interface which they see. Is the system easy to understand? Is the system easy to use? Can the user learn fast how to use the system? How is the human interaction between the system and the user? So how user feel about the system is the usability testing. So when the system is being deployed at the real working environment, how fast the user can use the system to do their task. If the usability is high, it means the system is good to use. If it's low, then it means user cannot understand the system is not user friendly, the navigation is not good. So this kind of issue might be this. Okay, so user interface testing, usability testing is more on how user feel about the system. Got it? Then after that we have security testing. So security testing is more about the security objective. So it means we want to see if the security measurement which apply on the system is working accordingly or not. Okay, so for example, when we set security measurement, how is the access level, who can use the system, how is the data protection happen, how the system is actually storing and sharing the data. So all this is part of the security testing. So here we will try to find where is the security holes happen. It means how the system actually can be attacked. So we want to confirm the security measurement is applied correctly, strongly. Okay. Then storage testing, it's more onto the storage objective, and this is more on the amount of the system memory or the size of the temporary memory or the log file. So this is to make sure that the system memory is enough, is usable enough, or there is any wastage happen. And the more the system being used, how is the system memory, the storage sizing happen, and it is still able to run the system correctly or not, and if it's affecting any of the process. Okay. Then configuration testing. So this one is more on the configuration. When we are going to install, when we are going to run the system, we need to know the configuration, the software, the hardware configuration, and if it's a web application, can it run on multiple devices, web browsers, multiple operating system. So this is more onto the configuration testing. Can it be configured without any problem or not? And then we have the compatibility and the conversion testing. So this is more focused on the compatibility. So for example, when we are doing integration with any other user interfaces from any other third party, so we want to know how is the compatibility, how it's actually working with another system, another server, or if there is any changes happen on the database, so how it's going to be compatible on whatever new. Okay, it is very important when there is any conversion happen or any compatibility integration happen, if the compatibility is correct or not. Okay. Then installation testing. So installation is more onto the installation procedures. Okay. So when we set as the system need to be installed, and we need to make sure that when we are dealing with the installation and we are having a proper procedures, documentation, user manuals, all this. So we need to confirm the installation is correctly done or not. So this is more to the installation process. Okay, then we have reliability testing. So reliability is more focused on the objective, on the reliability of the system. So when we say to reliability, it's more onto the available and also the downtime of the system. What is downtime? What is the downtime of the system? Downtime is what? When the system available or not available? When the system is not available due to any reason, due to any software hardware issue, network issue, or anything. Okay, even the coding problem. So when there is a downtime happen, okay, when a system is a good system, reliable system, it means the downtime must be less. So normally as part of the requirement, the percentage of allowed downtime will be always specified. So if the system is having more downtime, it means the system is not good. Okay, so we need to do the reliability testing also to check on the downtime. Then we have recovery testing. So recovery testing is very important for us to confirm is the system able to recover by itself or not. Whenever there is any issue due to any programming errors or any software failures, hardware failures, even the server, the database, whatever issue, can the system able to recover by itself or not? Okay, sometimes when you see any system, the screen is just display out there, the page cannot be found, or there is blue screen, black screen, because it is just waiting for someone to go and restart. So when the system is waiting for someone to go and fix it every time, it means the recoverability of the system is not good. So this recoverability is actually where the system should able to recover by itself when there is any issues happen. Whenever there is any functionality which is not working accordingly, it must able to recover by itself. So to confirm that, we need to conduct the recovery testing. Okay. Then we have serviceability or maintenance testing. So this is focused on the objective about the service of the system, the maintenance of the system. Okay, so it means when there is any issue, the services which need to be provided to the system to maintain the system. Okay, so this can be part of the system testing too. Okay, just because you have completed the development, you have tested it, you have deployed to the client, things over. Never. Because you will be still there to maintain the system, to provide the service to the system for the future use. So as part of it, the serviceability and the maintenance testing also need to be done. Okay, then we have the documentation testing. So this is more onto the documentation for the system. So we want to check on the accuracy and the clarity between the documentation which we have produced for the system is correct or not. Because this documentation will be what referred in the future. So if there is any issue with the documentation, then we might not able to understand the system correctly for us to maintain our services later. Okay. Then we have procedure testing. So procedure testing is more to the human procedure. So for example, for the system, we have all type of documentation procedures like the system operation, the database administration, even end users manual or any documentation which will be having a procedure like installation procedure, update procedures, okay, how to do certain functions or procedures. So all these procedures will be documented. So these procedures need to be tested to know if the procedures which we have prepared is correct or not. Okay. Then we have the acceptance testing. Okay, if you see until here, it is actually the higher order testing at the system level. Okay, so now once we have confirmed the system has fulfilled all these different types of the system testing, then we can move to the acceptance testing. So acceptance testing, like what we have discussed just now, we have different types of acceptance testing, but here what we focus is user acceptance testing. Okay, so user acceptance testing, we have these two categories, which is the alpha and the beta. This is what normally every companies they do, beta version. Okay, they release the beta version first. So all this is actually still at the user acceptance level. Okay, when they release the beta version, it's actually they want us to conduct the beta testing. So how the system is being accepted in the market will decide the final version of the system. Okay, so if you see acceptance testing or user acceptance testing, it means when the end user, okay, is conducting the user acceptance testing to the initial requirement which given by the end user. Okay, sometimes I think in 2163 you have discussed different types of software. Am I right? One is our requirement. what they call customized and generic. Correct? The two types of product, software product, customized and generic. Is it correct? Is it correct? Okay, customized means you come up with the requirement. You give the requirement. So the system must be fulfilling my requirement. If we say generic, do you come up with the requirement? But is it the software going to be for you? No. Huh? Do you come up with your requirement for this Microsoft products? Are you not using it? Are you not using it? Because they know that you will need this, am I right? So behalf on you, they come up with the requirement. But who is doing the beta version here? Who is doing the beta testing here? The end user, am I right? So they will still release the beta version. They will ask us to get it free, for example. We will try to use it so that we can see how is the development has been done before they come up with the final version, which they start to put the licensing there. Okay, so the same thing goes here when we said acceptance testing. Is the process of comparing the requirement and also the product which they have produced. Okay, so that user can know how they have come up with. Is it fulfilling the requirement? Doesn't matter either we customize the requirement or we don't. So they want to know if it's fulfilling what the client wants or not before they can come up with the final releasing. So normally user acceptance testing, we have these two categories. We will discuss later in chapter 3 of chapter 4. Okay, so alpha testing will be the first version of the user acceptance testing, and then we move to beta testing. Okay, so alpha testing will be still at the development side. Okay, beta testing will be at the real working environment or at the end user side. Okay, so when we set alpha test, it means when the system is like very close to end, very close to completion. Okay, they will conduct this alpha test by inviting end user to the software development site, or they can use their own internal staff who is not part of the development. It means they don't know anything about the requirement, they don't know about the design, they don't involve in the development. So just to pretend like they are part of the end user. So they will conduct the alpha test. So if you see this alpha test, there will be observation from the development team. Because development team want to know the feedback. When they do the alpha test, how user feel, what is their feedback, where is the issue, it will be still observed by the development team because they want to do the fixing. So when we set fixing after the observation from the alpha test, then they will move to beta test. So it means when we are conducting beta testing, it's after whatever changes done. So now we can assume that the system should be much more accepted or acceptable compared to what in the alpha test, because they already gather some feedbacks, some issues raised up, and then changes has been done. So this version will be depend on the company. They come up with totally beta version, or they do the beta test on the completed. It means whatever fixing has been done, and then they will be releasing it at the actual working environment or the real usage environment. The customer or the end user will be doing the beta test without any observation from the development team. Got it? Can understand? Okay, so alpha tests everything at the development side still. Okay, and when we say beta test, it means after they have do the fixing, everything is okay, now they move it at the actual working environment, the respective end users. No pretending all. It will be the actual end user will be using the system or testing the system during the beta test. Okay, so both of it is the acceptance testing, user acceptance testing, but they have different version, okay, or different level, alpha test and the beta test. Okay, installation testing is already done under the system testing just now. So the purpose is to find the to find any issues during the installation, okay, process. Okay, then as part of the usability testing, I have discussed on the user interface testing also, where it focuses on the usability criteria like the HCI, how is the user friendly, okay, how is the system easy to understand. So normally they will see how the user feel, the satisfaction through the any questions or any surveys, if the system is okay for them to use or not. Okay, then another important testing is regression testing. Okay, regression testing, before we discuss about regression testing, what you understand about retest or retesting? What is retesting? You have heard, right? Retest. Retest. What you understand about retest? What you do actually. Retest means what? Testing again. It means we want to repeat the same testing again. I have done the testing, and when I said I want to retest, it means I'm repeating the same testing for the second round. That is what we call as a retest. Repeat the test. Okay, when we said retest, repeat the test, we are repeating the same thing. Got it? When we said repeat the same testing, we expect no changes happen. No changes here means no changes on the test case, on the test step, on the test data, nothing changed. We are just repeating the same testing for the second round, for example. Okay, because you are too free, so you want to repeat the same testing for nothing. Clearly? Okay, that is retest. Okay, when we say the regression testing, it's something similar to retest, but with changes. So why there will be changes happen on your test case, on your test data, on your test action? Why you need to modify your test case for you to retest? When this will happen? When you need to change your test case. We will never change test case, is it? Whenever there is any changes happen to the source code, let's assume we identify defect and the development team do debugging. So there is changes happen on the source code, or there is new requirement coming in, new features need to be added, then development team do changes in the source code, correct? So every time when there is changes happen to the source code, possibilities for us to conduct regression testing is always there. So when there is changes happen to the system features, to the source code, there is possibilities changes need to be done on the test cases. So whenever there is changes done on the system, we must do regression testing. Can we have a fixed level when there will be changes on the source code happen? Can we? Can the source code change at the unit level? Can the source code change at module level? Can the source code change at a system level? Because requirement changes can happen at any time. Client can request something at any time. No matter which level are we, when there is requirement changes happen, automatically changes in code can happen. So regression testing, there is no specific level to be conducted, because whenever there is changes happen, we need to do the regression test. Okay? So if you see, regression testing can happen at the module level, at the unit level, at the integrated system level too. So based on the changes happen, we must immediately conduct the regression testing. Okay. My next question is, how should be regression testing like 10 years or 20 years back? Do we frequently do regression testing? 20 years back, for example. How was client that time? How was technology that time? How was their idea about system all that time? Until clients start to see things, everything was nice before. So it means they don't demand. When client don't demand, it means changes of requirement is less. When changes of requirement less, changes on the source code also will be less. I didn't say no changes at all. Will be less. Due to defect, yes. Due to debugging, yes. But due to keep on changing requirement will be very less. So in that situation, regression testing might be less too. Got it? But now, how will be regression tests? When there is frequent demand come in, frequent features, requirement changes happen, there is possibilities high regression testing need to be done. So due to this high regression testing, that is why we start to have automation testing too. Because testers get tired doing the testing manually for every single changes happen. So that is why we started to have automation testing tool to conduct the automated testing every time when there is changes happen to the source code. So the aim of regression testing here, we want to test every changes happen on the system to make sure that there is no side effect, there is no new defect is coming in. Because when there is changes happen, possibilities new defect to come up. So this regression testing is the way how we can monitor what is the effects after the changes happen. So the last time we test was before the changes. We can confirm, oh, everything was okay. But after the changes, if we don't do regression testing, automatically we don't know what the new changes come up with. The new changes can bring new defect. The new changes can disturb another functionalities. So we didn't know all this. So that's why every time when there is changes happen, we must conduct regression test to confirm the system has no new effects. Got it? So this is why when we said nowadays, requirement keep on changing, technology keep on changing. There is a lot of new things being asked by the client. There will be changes happen again and again. So in that situation, doing a manual recreation testing kind of difficult. So that's why we start to use this automation testing because of this. Got it? Clear? Okay, then we have the critical path testing. So critical path is about the main functionalities of the system, where the critical main functionalities must be covered first. So this is concentrate on the design, implementation and the testing to know the backbone of the system is working fine without any issue before we start with other functionalities. Okay, so normally when we are involved with any large project or any high critical project, we always put the critical path as the priority. So if you still remember your tutorial 1, the last question was about the prioritization of testing. What are the criteria which we need to check to prioritize our testing? So critical path is one of it. When we want to make sure that the main functionalities or the critical part of the system, it must be tested first. It's always have the higher priority, then we move to the low priority or low critical or the low modules of the system. Okay? Okay, so that's it for chapter 2. Sorry, I need to start chapter 3. Okay, any question? Chapter 2. So that was a different level of the system testing, where we start from the unit, we do the integration. So I have discussed the approach and then the strategy, and then if it's a newly developing system, we might have any missing part of the system which will need the driver and the staff to do the integration testing. Then after that we move to the higher order testing, which is at the system level. So as a completed system, as a complete integrated system, where we move more to the black box testing technique. What are the type of testing which we conduct as a system? Okay, so the third chapter here, we will be discussing about the static test. Okay, I have been saying about static test and dynamic test. Okay, so if you recall back, one of the testing principles said testing activity must start as early as possible. Okay, so this is why we have this static testing. Okay, we cannot wait to start the testing only after the development done, because if your aim is only I want to execute the system, I want to see what happened, that is considered very late, because your system is actually output coming from whatever documentation we have prepared earlier. What you put into your proposal, what you put in your requirement, what you put in your design, the output is actually the system. So if you wait for this system to be completed, then only you want to check if everything is okay, it is very late. Because if you don't test on the documentation, whatever issue on the documentation which we suppose should identify and fix in an early stage, you will never do that. When you don't do any checking on the documentation, automatically the defect in the documentation will be affecting the performance of the system later. So that's why when we say testing, we always have static testing and dynamic testing. Okay, I always use my left and right to separate them. Okay, static testing is on the left before the development of the system. Before before the development of the system. And dynamic testing can be considered on the right after the development of the system. Okay, got it? What we have before the development of the system? Before we do the coding, in the center here is doing the development. What we have before? Are we already having the coding? No. What we have? All the documentation. Am I right? Whatever you propose, your project planning, your requirement document, your design document, your UI design, all this is the documentation. Okay? And the center is doing the coding, doing the development. And on the right, after the development, what we start to have here? We have the source code, okay, we have the functionalities, we have the module, we have the integrated system, all this on the right. Don't you think the left and right here must be tally? Must work accordingly? What you said in your document, that's what will work on the system. That's why when we do the testing on the system, we check back based on our requirement. Correct? So, in that situation, if you did not confirm your requirement document is correct first, what happened to the system? Going to be a big problem later. Am I right? So, that's why when we do testing, we always start with static tests and continue with the dynamic test. Okay, so let's see what is this static test. Static test here, we are not going to run any system yet. Are we already having the system in the early stage? No. So, when we say static test, we are testing the system or any test object without running or without executing the code. In the easiest way, I can say that we don't even have a code yet. So, we have nothing to execute yet. So, when we say static testing, we are doing checking on other artifacts if there is any defect. So, other artifacts here will be more to our documentation. No matter how simple is your documentation, how complicated is your documentation, we still need to check this documentation. So, when we said artifact here, not only the code, anything else throughout the system and the requirement analysis, the design, your planning stage, all these need to be checked first. Okay, so we need to check the test object against to the documentation if there is any mistakes happen. So when we said doing checking on the documentation, are we testing it like how we test code? No. We still say it's a testing, but what we are doing is actually going to be different. Okay, so for example, what are the issues we want to check is like there is if any incomplete requirements, if there is any missing requirement, if there is any conflicts in the requirement, or if there is anything we did not meet the standards what it's supposed should be. So all these kind of thing we need to check on the documentation so that our dynamic testing later by running the system will be less issue. Why you need to do your project 1 first? Why don't you just go straight to your project 2? Can you directly go to your project 2? No. Why? Is it not wasting time to do chapter 1, chapter 2, chapter 3, chapter 4? Can I just directly do the coding? Okay, miss, we are done. Can I? Can I? Cannot. You still need to have some documentation in the early stage, am I right? To confirm this is what you are proposing. This is how you are going to work. This is what tools you want to use. This is your requirement. This is your design. All this need to be produced first. then only you can move to the requirement. So if there is any issue which we did not identify in project 1, what happened to your project 2? Fail and repeat. That is project. Let's assume it's an outside project. You are going to lose a lot of time, a lot of resources, a lot of money for nothing. Okay, so that's the reason why we must do the static testing first before we can do the dynamic testing later. So under the static test, we have a few different things which we will cover. So we have the review. Review is the most common word we will use for static test. When we review a documentation, it is part of the static testing. Okay, then other than that, we also will discuss static analysis, control flow analysis, data flow analysis. All these will be involved with the source code, but without running the source code, without giving any input and not to check any output. But it is all more to analyzing the source code if the source code is fulfilling certain standard or not. If you have prepared the source code correctly, efficiently, so that it will not affect the performance later. So we are not testing any code to see output at this stage. Correct? Got it? Okay. So the first one is the review. So review here is the most common generic term which will be used for static analysis technique or static testing. Okay, this is the most common word which will be used to review, because we want to review the document. Okay, so where people will be reviewing the specific document by using any techniques here. Later we will talk about different types of static tests. So this review also can be similar with inspection. You know, normally like your supervisor will review your document, am I right? Will review or will moderate your proposal, your documentation. So the same thing here. Okay, as part of it, inspection also can be done. But inspection will be a bit more formal review. Okay, so we will discuss later on the less formal and also more formal techniques under the static test. Okay, so review here where all documents can be subjected to a review or inspection. So start from your contract, start from your proposal, your project planning, your requirement document, your design, your test plan, test case, even source code, everything need to be inspected or need to be reviewed. Okay, so this is part of the static test. So when we set review, we want to make sure that the document is correctly prepared. So there is no missing thing happen, there is no conflict happen, there is no something else what the client said. That is very important if we want to identify all these issue, accuracy, and there is any inconsistency happen in a very early stage. Because what you don't correct in the requirement level, it's going to it's going to affect the user acceptance testing later. Because this requirement is not what I say. So this is not the system what I'm going to accept. So that's why it is very important to do the review on the documentation in a very early stage. Okay, so when we said review or the static test, the positive effect here is the defect elimination process is very cheap. Because what you are dealing here, just a documentation, and if there is any mistake on the documentation, you just correct the documentation, done. compared to you have a complicated of source code. You are dealing with thousands of line of code. You do the testing, you identify the defect, you need to report to the development team. The development team need to go and having sleepless night to find the root cause, where is this defect happen, and they need to do the debugging. When they do the debugging, there will be a lot of changes happen on the source code, and then we need to conduct regression testing. I'm tired really. So there is a lot of waste of time, resources and budget, and this might be affect our project timeline. So that's why whatever defect we identify during the static test, during the review, will be much more easy to eliminate. Got it? The second one is it can be helpful to shorten the development time. If your documentation is clear, you understand the documentation, you have fixed all the issue in the documentation, how will be our coding development process later? Will be easier, will be less issue, everything much more accurate. There is no confusion happen, there is no issue happen. So the development team can have shortened development time without any confusion. This can be helpful or not? Yes, because later we can move our testing and our other activity earlier, and it can shorten the timeline of the project. Okay, then the third positive effect will be cost reduction. So when we said to identify and do fixing at the early stage, it is always much more easier than dealing something on the system later. So automatically it can reduce our budget for the overall project. Whatever issues which we deal at the early stage, identify the defect on a documentation and fix it, it's going to be very helpful, because we are not going to waste a lot of money in the testing and in the debugging process later. Remember, one of the advantages of the incremental model, early detection of the programming error and the easy debugging process, similar thing. If it's easier to do in the documentation, why you want to kill yourself later? Do it now, because it can be helpful in the cost reduction for the entire project later. And automatically, if we do review, if we do inspection on the documentation, it can reduce the failure rate on the final system later. Okay, so the aim of our static test is we want to prevent failure. We can reduce the failure rate on the dynamic testing later. Because dynamic testing is where you are executing the completed system or the completed code to confirm what you have mentioned in your documentation. Got it? That is no more preventing. That is to identifying so that you can fix it. So if you can reduce all those numbers of defect in the documentation, it means your dynamic testing later will be easier, will be less issue, so that you are not going to be wasting a lot of time, a lot of cost later. Got it? So now you understand why I put static testing and dynamic testing on the left and right before the development and after the development. Because when we conduct the review, we do the static test, it's actually to prevent whatever negative thing can happen on the system later. We can avoid some things from happening. But when we set after the development, Dynamic testing is all about to identify what we missed out earlier. It means we want to identify the defect and no choice, there is no prevention anymore, but we need to identify and we must do the debugging. So the more we are doing the static testing, the more easier will be our dynamic testing later. So in that case, can we skip static testing? Can we say that, no, we don't want to do review? Can I say that we don't want to do review on the documentation? Let's assume if your supervisor say that, I'm not going to review your chapter 1 until chapter 4. Come up with your project later. And then after you come up with your project, when you do your system testing, your supervisor say, this is not good. You know, that is what happened here. So if you don't review on your documentation, later it's going to be a problem. Okay, so when we say to review, we have this 6 different review process. Okay, this is a process, a flow of the review process, where we start with planning, then we start with kick-off, then individual preparation, review meeting, rework, and follow-up. This 6 process must happen in this flow. It's like a step-by-step flow. So, let's see one by one. The first one is the planning stage. Planning stage here means we need to decide which document in the software development lifecycle now we want to review. Are we going to review SRS? Are we going to review the design document? Are we going to review the proposal, project planning? We need to decide which document we want to review. And according to this document, we need to know which review technique is suitable. Can I review SRS and your SDD in the same way? Can I use the same people to review the requirement and the design? Can I? They suppose should come from the respective domain. They need to have the knowledge about requirement, the knowledge about the design, so that they can understand, they can review the document. Just because the person know requirement, can I push them into the design? Cannot. If they don't have the knowledge, it means they cannot do the review. And at the same time, at the planning stage, we will form the review team. Got it? Okay, this is what happened at the planning stage. After we have choose the document, we know who are the people, what is the technique, we have formed the review team, we move to the second stage, which is the kick-off. Not kick-out, kick-off, which is the overview stage here. So what happened here is, all the relevant information about the review meeting, when we are going to conduct, where we are going to conduct, what date, what time, all this information need to be shared out to the review team. Okay, and at the same time, the document which need to be reviewed will be shared out to the reviewers. At this stage, the document need to be reviewed. Okay, so let's assume we say SRS. So the SRS is going to be shared out to the reviewers. Normally, we will not have one reviewer. We will have multiple reviewers, 2 to 3 reviewers, for example. So this stage, the secretary, okay, of the company will be the one doing the sharing. Every review team members will be updated with the information, but the reviewers will be shared with the document which we are going to review. Okay, the reason why the document will be shared out to the reviewers, because of the third stage, the reviewers need to do the individual preparation. Okay, before the actual review meeting will be conducted, the reviewers need to study the document earlier. They need to check the document against to the standard, against to their experience, against to their knowledge. If the document has been prepared correctly, if there is any issues, if anything they don't understand, they need to clear up. If there is any comments, any questions, the reviewers will be study the document earlier before the review meeting. Only the reviewers who has been shared with the documents will do this. Got it? Because during the next stage, review meeting, we are not going to study the document at that time, but they are going to start to voice out whatever they have identified during the individual preparation. Do you get? Do you understand why the individual preparation comes first? Because the reviewer need to spend few days or weeks earlier for them to study on the document, to identify whatever they need to identify from the document, so that during the stage 4, during the actual review meeting, they will voice out everything. Not wasting time to be studying the document at that time. Review meeting always have a limit time. Let's assume 2 hours, 3 hours. Within that 3 hours, the entire documentation, individual preparation has been done by the reviewers need to voice out. Okay, so the actual review meeting will be conducted or will be led by the review leader, or we call them as a moderator. So they will be the chairperson. So this chairperson will allow all the reviewers to voice out from their finding during the individual preparation. So you must voice out. If you are the reviewers, you must voice out whatever comments, whatever question, whatever you identify from your study. Okay, so this review leader or the moderator will be doing the recommendation according to the reviewers' feedback. Either the documentation can be accepted, or the documentation need to be corrected, or the documentation need to rewrite completely. So the chairperson will be the one give the final recommendation. And all the reviewers, because you are 3 to 4 reviewers for example, all must agree to the final recommendation done. Is the author of the documentation part of the reviewers here? Never. So here the author cannot say anything. Whatever reviewers is giving the comments, the final recommendation given by the chairperson, later the author will work on it. Okay, so review meetings actually can turn into a fight. Can. And it can go more than the given fixed timing. I was in industry before, I know. Okay, so the chairperson must be a very strong, firm person to conduct the meeting, to make sure the objective of the review meeting has been achieved within the fixed time limit. Got it? Can understand how the flow happens? Start from the planning, move to the kick-off, and then individual preparation and the review meeting itself. Clear? Okay. Then the fifth one will be the rework. So rework here will be the project manager will decide either to 100% follow the chairman recommendation or to suggest to do something else. Why the project manager? Because they are the one know about the timeline, about the resources, about the budget. So if they do something out of the recommendation, how it's going to disturb other things. So that's why the project manager will decide either to follow the recommendation or to suggest something else. According to that, the author will do the rework. Who is author here? Who is the author here? The person who prepared the document, am I right? If it is SRS, it means the requirement engineer who prepared the SRS, for example. So the author will follow the recommendation or decision, and then they will do the rework, either to correct the document or totally to come up with a new document. Okay. Then the sixth process will be follow up. Can I just blindly trust the author? Oh, everything has been done. No. So the project manager or the review leader or the chairperson just now must do the follow up to see if whatever changes made by the author is correctly done or not. Okay. So if everything is settled, the review is successfully done. If after the follow-up they identify something is not acceptable, second review will be scheduled. So the more the documentation is being finalized, we can end the review. If no means, review will be keep on happening. Okay, so that will be the sixth process of the review. So make sure you remember the flow. Start from planning, kick off, individual preparation, review meeting, rework, and the last one is follow up. Okay, so we will stop until here, then we will continue the balance part.
我医生在开着嘛，放在那个那个水，我忘记说了。